All right, I have no idea how to solve this one. Let's see. It accelerates from rest a distance of 3.27 up the ramp in 1.81 seconds. Doesn't it seem like we need to solve for the acceleration? Oops, that's 7 meters, right? It does in 1.81 seconds. So I think what we're going to do is we're going to use 1 FAT squared or something like that, right? All right, so let's find the acceleration. Acceleration is going to be 2s over t squared. So it's going to be 2 times 3.27 divided by 1.81 squared. So 2 times 3.27 divided by 1.81 squared. And I'm going to store that in A for acceleration. A is for acceleration. So that's 1.99627. 1.99627 meters per second squared. Okay. This has bought me some time. It looks like I know what I'm doing, but I deeply don't. Okay, it's accelerating up the plane. I think we got to, let's just keep going. Let's set up, what would we do? Well, we have the mass of A, right? So it seems like a logical thing to do is to find that parallel force down the plane, right? That's going to be mg sine theta, right? So I'm going to go 4.51 times 9.81 times sine of 25 degrees, right? Apparently this is 25 degrees still. Seems like we need to know this, right? This will help. So 4.51 times 9.81 times sine of 25. I'm going to store that in B just for fun. 18.698. Okay, so that's this force here. That's 18.698 newtons. Okay. Wow, what do we do? Let's just keep going. Let's pretend like we know what we're doing. The problem is we don't know the mass of this guy. So let's just see. So for A, F equals ma looks like this. We've got, it's accelerating this way, right? So here's our tension. So it's tension minus 18.698 equals 4.51 times, our acceleration is 1.99627. Ooh, that's good. We can solve that for t, right? Yeah. Okay, this is looking up. Looks like we're going to be able to do this. Okay, so let's solve that for t just for fun. Okay, so t is going to equal this plus that, right? So this plus 4.51 times that. 27. So t from this equation is just simply solvable, and it's 27.7011 newtons. Okay. Didn't ask to solve for t, just asked for what the mass of B is, but we've got that, right? So now let's set up B. B, we've got a force of mg down and a force of t up, right? So this looks like 9.81 m minus this guy minus t, right? Equals m times 1.99627, right? Again, we're just setting up F equals ma, right? So this is actually really good news for us because we've got 9.81 m minus a number now, right? 27.7011 is equal to m times 1.99627. Well, although there is two m's there, they are the same m. We can combine them, right? So I'm going to have m outside of 9.81 plus, or wait, no, minus 1.99627, right, equals 27.7011. Oops, we've got a dog alarm going off here. Okay, so 9.81 minus what I've got for the acceleration, right? So I've got m times 7.8137 equals 27.7011. Okay, and so I guess we just divide, right? 27.7011 divided by the answer I just got. I get 3.54518. Kilograms, right? I guess I would have to say that that's actually 3.55. Kilograms, a slight adjustment there. All right. So there you go. Basically, just if it's a weird problem like you're trying to solve for the M or something like that, right? Just proceed like you know what you're doing, and if you need to tell a few jokes while you're doing that, that's good, right? If there's a Suvat problem, solve the Suvat problem. If you can find one of the forces, find the force, right? And then just sally forth.